Hello student, our first chapter is completed. Now let us see our next chapter, electric current through conductors. Okay, आपला इथे फर्स्ट चॅप्टर कंप्लीट झाला आहे. आपण सेकंड चॅप्टरकडे जातोय, इलेक्ट्रिक करंट थ्रू कंडक्टर्स. So now what is electric current? So electric current means the rate of flow of electric charge through any cross section of the conducting wire in the electric circuit is called electric current. And we know the conductors. Conductors means which carried a electricity is called the conductors. Okay, so here electric current means current denoted by capital I is equal to Q upon T. By definition, we get a formula I is equal to Q upon T. Here Q means rate of flow of charges in between a period of time T. So here SI unit of electric current is ampere. So hence 1 ampere is that current which is produced in the circuit when 1 coulomb of charge flows for 1 second, means 1 coulomb of charge flows 1 second through any cross section of the conductor. So while the current in the household circuit could be of the order of few amperes, so current of the order of milliampere, microampere or nanoampere. So here current also measured in the form of these milliampere, microampere, nanoampere. Okay, so current can be generated by positively or negatively charged particle in an electrolyte. So both positively and negatively charged particles take part in a conduction, and in metal the free electrons are responsible for conduction. So these electron flow are generated a net current under the action of an applied electric field. So as long as the steady fixed circuit exists, the electrons continue to flow in the form of steady current. Such steady current electric fields are generated by cells and batteries. So current is also expressed in a limit of the ratio delta Q to delta T, and delta T tends to 0. Let us see our next point in the chapter is electric energy and power, and because of COVID omitted some points in this chapter. This is drift velocity and Ohm's law and limitations of Ohm's law. So this point is we also omitting and directly come to our next point, electric energy and power. Okay, so we know that what is the Ohm's law, because in 10th standard we already learned Ohm's law. V is equal to IR. V is the voltage, I is the current, and R is the resistance. So V is equal to IR, and we know that Ohm's law. So directly come to the next point. Okay, so now in electric energy and power, so we know that what is the energy and what is the power. So let us see this figure. So here resistance, this is the symbol for resistor. So here the first terminal of the resistor is A and second terminal of the resistor is B. V is the potential difference between this resistor, means between this terminal A and B. Okay, I is the current flowing through that circuit, and this symbol for the battery or power supply. So first big straight line denoted a positive terminal of battery or power supply, and small straight line denoted a negative terminal of the battery or power supply. Okay, so current flowing through that circuit from terminal A to B, means charges flowing through that circuit is opposite direction, because charges are flowing opposite direction of the current. Okay, so consider the resistor AB connected to a circuit cell in a circuit as shown in figure. Okay, this is the also symbol of the cell. Okay, with the current flowing from A to B, the cell maintains a potential difference V between two terminals of the resistor, a higher potential at A and lower at B. Okay, so consider a resistance AB connected to a cell in a circuit as shown in figure with current flowing from A to B. So let V is the potential difference, A is the higher potential terminal of the resistor, B is the lower terminal of the resistor, and Q be the charge flowing in time delta T. And here W is the work done, because charges are flowing, so work is done. So we get V is equal to W upon Q, means here work done upon total charges flowing through that circuit. So we get W is equal to, means work done is equal to V into Q. So this is the first equation. So the potential energy is nothing but in the form of work done. So this work done is written as a potential energy. So delta U is denoted a potential energy is equal to Q into V. This is the Q into V is equal to I into delta T V. So we know that I means current is equal to Q upon delta T. So Q is equal to I into delta T, charge flowing of charges in small time delta T. So here put up a Q is equal to I into delta T V. This is the second equation, and where I is the current due to the charge Q flowing in time delta T. So in the limit as delta T tends to 0, so du upon dt is equal to IV. Delta T return is a dt form also. We know that delta U upon delta T means du upon dt is equal to I into V. This is the equation number 3. So here delta U upon delta is power, the time rate of transfer of energy is given by. So now here energy is given by. We get here power P is equal to du upon dt, means du upon dt nothing but power. So it's equal to I into V, equation number 4. So the energy dissipated in time interval delta is given by equation 2, and the energy dissipated per unit time is actually the power dissipated and is given by equation 4. So using equation 4 and using Ohm's law, V is equal to IR, we get the equation P is equal to V square upon R. Means here put up P is equal to here I is equal to, in equation 4 put up the I is equal to V upon R by using this Ohm's law, V upon R, and then we get here P is equal to V square upon R. And suppose we put in P is equal to I into IR, V is equal to IR, and we get I square upon R. So P get is V square upon R or I square upon R. This is the equation number 5, and it is the power dissipation across the resistor. So why it is energy dissipated? So because of the presence of electric field, the free electrons move across a resistor, and there would be an increase in their kinetic energy as they move. When the electrons collide with the iron core, energy gained by the shear among the iron cores, consequently vibrations of the ions increasing and resulting in a heating up of their resistor. the sum amount of energy is dissipated in the form of heat. म्हणजे ते एनर्जी थोडी लॉस होते कशामध्ये हीटच्या फॉर्ममध्ये डिसिपेटेड होते. सो द एनर्जी डिसिपेटेड पर युनिट टाइम इज ॲक्च्युअली द पॉवर डिसिपेटेड अँड इज गिवन बाय P is equal to V square upon R is equal to I square into R. Okay, this power dissipation is responsible for heating it up. Means, for example, filament of electric bulb heat up to incandescence, radiating out heat and light. Okay, आपण तुम्ही बल्ब मध्ये बघितले ती फिलामेंटची जी वायर असते ती तापते, गरम होते बिकॉज ऑफ डिसिपेशन ऑफ एनर्जी. ओके, इथे आपला हा पॉईंट कम्प्लीट झाला आहे.